Kia ora Year 12 and Year 13. This is a complex numbers scholarship calculus question from back in 2009, but it's really a trig problem. So this is the question here. It's worth 3 marks and it's pretty doable. But what I want to do first, and I'm going to go quite slowly today, is to think about what you notice when you're doing this question and what the clues are about how it's going to fall out. So we start off by being given a complex equation. And this is it here. And we're told that this complex equation is equal to u plus iv. And we have to show that u over v is equal to cot of 3 theta. So let's look at what role the complex numbers plays in here, because it's actually pretty minor. What we're going to do here is we're going to expand this, and then here u is the real part of the complex number that I get, and v is the imaginary part. So we're going to take those two parts and show that 1 over the other is equal to cot 3 theta. So step 1 is to just get on with it and expand the left-hand side of that equation. So here comes the first little bit of complex numbers remembering. And I'm assuming some of the people watching Year 12s who have just started working on scholarship problems. So some of the things I'm talking about here require good knowledge of level 3. You might want to go and find the level 3 complex numbers videos to brush up your complex numbers skill. So cis theta in maths is shorthand for this. And we've got some really convenient rules that let me work easily with multiplication in polar form. And the main rule is this one, that R cis, or R1 cis theta 1 times R2 cis theta 2 is equal to R1 R2 cis theta 1 plus theta 2. In other words, when we multiply two numbers that are in polar form, it's really easy. We just multiply the moduli and we add the arguments. And I thought of this was the stupid acronym that we thought of in our class last year. So that's going to simplify this part here as follows. So let's just put all of that into a little bubble. So we've got 1 plus cis 2 theta plus cis 4 theta, and then the last term simplifies to cis of 6 theta. So that's my complex equation. Now the next step is to get the real parts and the imaginary parts for each of those. So we have 1 plus cos 2 theta plus I sine 2 theta, and so on. So plus cos 4 theta plus I sine 4 theta plus cos of 6 theta plus I sine 6 theta is equal to u plus iv. So let's look at the real part of each of those and the imaginary part. So reordering, 1 plus cos 2 theta plus cos 4 theta plus cos 6 theta plus I times these things. Right, so that's actually going to be the end of the complex numbers part of the question. What do I have to do now? Well, I need to work out what u over v is. So u over v is equal to 1 plus cos 2 theta plus cos 4 theta plus cos 6 theta over sine 2 theta plus sine 4 theta plus sine 6 theta. Now this is a proof question, so whenever I'm doing a scholarship proof question, I want to look really hard at where I'm going, because there are a lot of different options usually for where I can head. So let's go back to the question and see what we're trying to get to. Well, we want to show that u over v is equal to cot of 3 theta. Now cot of 3 theta is equal to cos 3 theta over sine 3 theta. So my goal now should be to look for ways to work 3 theta into my answer, and I can feel that I'm going to end up doing some factorising. So there are a couple of things that come up over and over again in scholarship calculus, and one of them is the double angle formulae, and you can just about see it here already. You've got cos of 6 theta and you're heading for cos of 3 theta. So that's looking good. We're going to do a double angle thing here. And the same thing down here. We've got sine of 6 theta, so we're going to use a double angle formula. That's going to be step 1. If you're tempted to go to the formula sheet, if you're new to doing scholarship calculus questions, one of the very first things you should do is get so good at your double angles that you memorize them. And there are 2 of them. So cos of 2 theta is equal to 3 different things. Cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. When I'm working with a double angle, an intelligent choice of those can make things much easier. And in the numerator, there are 2 clues for which one of these I want to pick. The first clue is that I've got a 1 plus here. And I'm thinking already about factorising, and I don't want to have a 1 plus in there. So the version that's going to undo the 1 plus is going to be this one here. On top of that, I want to end up with cos of 3 theta in my numerator, so up here. And if I use this one, I'm going to get sine coming in. That's bad. And I almost never want to use that one. That one will usually make my life worse. So the double angle formula that I'm going to choose here is the middle one. Right? The trick here is that I've got cos of 6 theta, not cos of 2 theta. For the sine double angle formula, happily, there's only one. So sine of 2 theta is 2 sine theta cos theta. So the next step here is to apply the double angle formula to each of those. Believe it or not, if you do that step, this next step, you're going to get 2 out of the 3 marks for the problem. So we now end up with this. U over V is equal to 1 plus cos 2 theta plus cos 4 theta plus 2 cos squared 3 theta minus 1. And in my denominator, I get sine 2 theta plus sine 4 theta plus 2 sine 3 theta cos 3 theta. So just one more time, the 3 thetas are coming in because in here I've got 6 theta. Right, so when we use the double angle, we start with a 2 times whatever, and then we halve it here. Right, so we can see that we're making good progress. We've got rid of the 1s and we've got a 3 theta coming in. Sorry about the computer making a big fan noise. I've got no idea how to stop that. Can someone please let me know if that's turning out to be a problem? Okay, so now I've got a whole lot of stuff that I don't want. And this is where I probably might go and look at my formula sheet, because what often will help is I'm trying to factorise. I've got this plus this. So we can use our sum to product formula. And the same thing here. I've got this plus this, so I'm going to use my sum to product formula. So here's the excerpt that you want from your formula sheet. These sum to product formula are really useful, but I find them quite hard to memorize, at least until I get back into trig every year. So the one we want here is going to be the cos plus, this one here, cos C plus cos D for my numerator, and sine C plus sine D for my denominator. So pause the video and have a go now at applying those formulae. Okay, so it's probably worth writing those out. So we've got cos of C plus D is equal to 2 times cos half the sum, cos half the diff, and sine of C plus D is equal to 2 sine half the sum, cos half the diff. So again, we're going to chuck that into a wee bubble and keep on going. Now, what can I do with cos 2 theta plus cos 4 theta? Well, it's going to be 2 cos half the sum, 2 theta plus 4 theta, 6 theta, over 2 cos half the diff. So 2 theta minus 4 theta over 2 plus what we already had. So that's the numerator done. Down here we get 2 sine half the sum, so 6 theta over 2 cos half the diff plus 2 sine 3 theta cos 3 theta. So you're probably thinking, well, nothing's coming out yet. But again, you can see that you've got this turning into a 3 theta and the same thing here. And hopefully we're going to have some factorising. Right, I'm going to divide everything through by 2 now. And I get cos of 3 theta, cos of, right, what have I got? Negative theta plus cos squared 3 theta divided by sine 3 theta cos of negative theta plus sine 3 theta cos 3 theta. Now the other idea that comes up over and over, which you'll know if this is your second go through at scholarship, is the idea of odd and even functions. So cos of 3 theta cos of theta plus cos squared 3 theta over sine 3 theta cos theta plus sine 3 theta cos 3 theta. Right, now let's simplify by taking out a common factor. We'll take out the cos 3 theta because we know that's what we want to end up with. We've got cos theta plus cos 3 theta over sine 3 theta into that same factor. So this is the part of the proof where you are suddenly very, very happy because you can see the whole thing disappearing. And we get equals cot, whoops, something's happened to my pen. Nope. Okay, cot 3 theta as required. So I know this video is already long, but there are a couple of things I want to go over in case there are any new students watching. One is that because we're doing a proof, you've got to make sure you show every little step, so don't leave anything out. And there are a whole lot of really important trigonometry ideas in this proof. So please, if you don't understand, leave me a comment and I can point you to one of the level 3 trig videos, or go and grab a copy of the Delta textbook and go through the relevant parts in there. Thanks for watching. Sorry this was a wee bit long.